The diagram represents an open water trough of a length 80 centimeters. The cross-section is an isosceles trapezium of parallel sides, 54 centimeters and 24 centimeters, with slant sides of length 25 centimeters and height 20 centimeters. So here's the diagram that represents this information. Calculate the area of the cross-section. Now the cross-section of this shape is a trapezium. So this is a cross-section, right? And so we have to figure out the area of the trapezium, all right? And so the area of a trapezium is equal to half A plus B times H, all right? That's the area of the trapezium. And the cross-section and the cross-section of the shape is a trapezium. So we have area of the cross-section is equal to half, open bracket, A plus B times H. Now, what is A, what is B, and what is H, right? So A is going to be this length right there, all right, this length. And this length is 54 centimeters. And we know that because this is 54 centimeters and they have the same size. And so that's why this is 54 centimeters. And B is 24 centimeters because that's this length right there. And so this is B, 24 centimeters. And the height is definitely 20 because this is 20 right there. So this is the height. And so we have half of, open bracket, 54 plus 24, close bracket, times 20. Now what is 54 plus 24? 54 plus 24 is 78. And so we have 78 and we have 20 right there. So we have half times 78 times 20. And so what we do here is we take a half and we turn it into a decimal. So it's going to be 0.5. So we have 0.5 times 78 times 20. When we multiply them together, we get 780 centimeters squared. So the area of this trapezium, or the area of the cross section, is equal to 780 centimeters squared. Next, we have to figure out the volume of the trough. Now, the volume is going to be equal to the area of the cross section multiplied by the length. We just figured out the area of the cross section, that's 780 centimeters squared, and 80 centimeters is the length. And we know that because that's this, all right, it's 80 centimeters. And when we multiply these two together, we get 62,400 centimeters cubed, and that's the volume of the trough. All right, next we have to figure out the total surface area of the trough. And in order to do this, we're going to figure out the area of each of the sides, all right? And once we figure out the area of the sides, then we add them together, and then that'll be our total surface area of this shape. So we have to first figure out the area of the front trapezium. And so this is the front trapezium right here. A is 54, right? A is 54. B is 24, right? That's why we have 54 plus 24. And the height is 20. And so we have 20 right here. And when we perform the calculation, we get 780 centimeters squared. All right, that's the area of the front trapezium. Now we need to figure out the area of the back trapezium. Now the area of a trapezium is half A plus B times height. Now what is A? Well, A is 54 centimeters. So this is 54 centimeters. What is B? B is the size of this at the bottom. Okay, this length at the bottom, and that is 24 centimeters. So we have 54 plus 24, and the height is the same. The height is still 20 centimeters, all right? And so the area of the back, the area of the front trapezium and the area of the back trapezium are the same. It's 780 centimeters squared. Next, we have to determine what is the area of the bottom rectangle. And so we have a rectangle at the bottom, okay? And we need to figure out what is the area of this bottom rectangle. Now, we have the length, which is 80 centimeters. So this length right here is 80 centimeters. The length right here is 80 centimeters. And we know that because this is 80 centimeters right here. So this one at the bottom here must also be 80 centimeters, okay? And so we have 80 centimeters multiplied by 24 centimeters, because if we look carefully, this is the length, all right? So this right here is the length, and then this is the width. So area of this rectangle is going to be length times width, which is going to be 80 centimeters multiplied by 24 centimeters. So it's 80 centimeters multiplied by 24 centimeters, which gives us 1,920 centimeters squared. And that's the area of the bottom rectangle. Now we need to figure out the area of the right rectangle. Now, the area of the right rectangle is going to be, now this one right here is, this length right here is also 80 centimeters because this is 80. This one right here, this length right here is also 80. And so that means that this one right here is 80 centimeters as well. So this right here is 80 centimeters, that's the length. And the width is this 25 centimeters. And so we have the length, which is 80, and the width, which is 25 centimeters. So 80 centimeters times 25 centimeters gives us 2,000 centimeters squared, and that's the area of the right rectangle. Next, we have to figure out the area of the left rectangle, and the area of the left rectangles, or the rectangle on the left, is going to be 80 centimeters, right? 80 centimeters multiplied by 25, because this right here is also 25, all right? And so 80 centimeters multiplied by 25 centimeters gives us 2,000 centimeters squared. And so we have all these areas and we need to figure out the total surface area. So we're going to say 780 centimeters squared plus 780 centimeters squared plus 1,920 centimeters plus 2,000 gives us the total surface area of the trough, which is going to be 7,480 centimeters. And that's the answer to this question. That is the total surface area of the trough.